There are at least 3 or 4 formulas out there to calculate areas of triangles. In this short video, I'll show you how some of those formulas are the same and a little bit about order of operations when it comes to working with a formula. So typically, in a triangle, the area of a triangle has to do with the base of the triangle, typically abbreviated with a Latin lowercase b, stands for base. And in this case it just happens to be 3. And the other part in the calculation is the triangle's height, usually abbreviated with lowercase h, stands for height. Or sometimes A for altitude. It's, if you like Latin and fancy words, call it altitude. If you like plain words, just call it height. It's the same thing. One is in English, the other one is in Latin. If you want to go for fancy, go for altitude. There is a reason for the distinction. 3D shapes like cones and cylinders would have an extra, you would have an extra word available for indicating the height of those shapes. So A stands for altitude. So these things basically mean the same thing when it comes to triangles. And so typically the formulas would run that that area equals base times height divided by 2. Actually, let me just do that one in red. There, base times height divided by 2. So that's one way to write the formula. Let's calculate with this one. The base is 3. Oh, I forgot to write up the height or altitude. Here is in this case 4. So to calculate with this one, we'll need to multiply 3 with 4. That's bad, I'll just fix it. Sorry. 3 with 4, you know that 3 times 4 is 12. Divide that one by 2, that's going to be 6. Another formula that you might see in your books, and depending on how publishers format the different formulas, might be this. Base divided by 2 times height. Same stuff for the area of the triangle. So let's do this one. The base is 3 in this case. 3 divided by 2, that's 1.5. And you have to times this by the height, that's 4. 4 times 1 is 4. 4 times half. 4 50 cents make $2, so 4 times 1 is 4 plus the 2, that's going to be 6 as well. So if your formula is formatted this way, it's the same thing. The third one that I often see, very similar to these ones, is base times height divided by 2. Guess what? It's going to be the same. Base being 3, so you take the 3 and you're multiplying it by half the height. The height is 4, half of 4 is 2, so it's multiplied by 2. You know that 3 by 2 is 6. One last version. Sometimes the area is calculated by 1 over 2 half times base times height. Guess what? It's going to be the same. Base is 3, height is 4. 3 times 4 is 12 times half. If you do it on a calculator, 12 times half, it's going to be 6. Alas. Apparently, order of operation doesn't make a lot of difference. Take a look. All of them come up with the result that the area of this triangle is 6. And as long as a critical factor here, as long as the 2 is a divisor, and then you do 2 pieces of multiplications, the 2 is always consistently a divisor, okay? There, 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 and there. As long as the 2 stays the divisor and then you multiply it with the other 2 numbers, you should be fine. And because multiplication is commutative, you know that it can be H first and B after, or you know, the order which B and H are listed, it doesn't really make a difference to it. 3 times 4 or 4 times 3, it's going to be the same. So that's just a little bit of food for thought. No matter which way your formula is formatted by the publisher, or whatever handout you have in your minds, it's going to be, or in your hands, it's going to be all the same, given a little bit of caution.